Hey everyone. Hi, my name is Rohan. I'm your host for the night. I hope I'm audible and my screen is visible and I'm visible as well. If you could drop in a quick yes in the chat, that would be super helpful. Um, yeah, thank you so much for this quick reward, folks. So before I dive into today's session, which is AI system design, learning how to build robust and scalable AI systems with Ahmed, I'll quickly run a very small poll. And just give me a sec. One sec. Yeah. So the poll will do respond to this poll. This poll will help Ahmed understand who his audience is, and he can tailor his delivery as per the expertise level of the folks that have tuned in. There are three questions. Two are something that will help us understand you better. One is what best describes your short-term slash long-term career goal. This is more to understand what are you looking for. Are you looking to prepare for interviews in the current AI era? Or are you looking to upskill in your current role with agentic AI and GenAI? Or are you looking to transition to a full-fledged AI role? The second question, which is super helpful for us to understand what your current expertise is, which is how AI ready are you today on your upskilling journey? Whether you're just starting learning to work with LLMs, or whether you're creating boosting productivity with AI copilots, or you're already building AI agents, or you're working with advanced ML and deep ML models. And lastly, if any of you who is interested in knowing more about offerings, how Interview Kickstart can support your career goals, or in general get a career consultation with us, do drop in a yes to question number three. We'll be happy to reach out to you. The poll is live. There are almost 200 odd folks. I'll really, really appreciate if you could answer question one and question two at least, if not third. It will hardly take a second of yours, but it will be really helpful. So without further ado, I think this acts as a filler also, what I do in the beginning. So it gives more people time to tune in. Um, Coming to today's agenda, I'll very quickly, without wasting much of your time, get into that. We'll quickly start with like a very 2 minute introduction to Interview Kickstart. Then Ahmed has some strong notes on building ML AI systems. Then he'll share the problem statement, the scope of the problem, then identifying key components, then operational LLM ops, and then privacy, security, and compliance. And then there'll be a small picture on Interview Kickstart in the end. Coming to how Interview Kickstart is. Interview Kickstart is, I'm sorry, yeah, fair, sorry, no, nothing. I thought I was on mute for a second. My bad. Yeah. So coming to who Interview Kickstart is, we are a decade-old company, and we are a guru platform for AI upleveling and AI interview prep. We take project building based FAANG plus approach to AI and ML. If I were to give you like key metrics that really showcase our expertise, like I mentioned, we are in the industry for almost 10 years. There are 25,000 plus people who we have served so far. There are more than thousands of our alumni who are already in tier one companies. In terms of our outcomes, there we have 24 specific curricula that so we heavily focus on personalization. Average student compensation from a course is somewhere 250K, and the key value proposition that we bring to the table is we have tied up with more than 700 plus FAM plus instructors who have 70 and there's 70 plus dedicated AI ML instructors. And not just that, collectively, if I look at their average experience per instructor, that's almost 13 years. So the core piece being our curriculum is built and delivered by FANG Plus instructors who are in senior positions with at least 13 years in FANG on an average. They are the ones who are helping us build this curriculum, deliver this curriculum. And one such subject matter expert with us tonight is Ahmed. Ahmed is currently an applied ML engineer at Google. He's currently teaching applied ML at Interview Kickstart as well, and he has done his master's from University of Waterloo and Purdue University. Ahmed, can we have you on screen, please?
Hello. Thanks, Rohan, for the
Thank you
introduction.
so much, Ahmed. Thank you so much for taking this up. I'll stop sharing my screen.
All right.
Ahmed, very quickly, I'll just give you the poll answers. What are the answers so far? So, in
Sure.
terms of what describes best your short-term slash long-term career goal, almost 80% of people are looking either to transition to an AI role or upskill in their role with the Agentic and Gen AI. In terms of where is your audience currently with regards to the upskilling journey? 34% are just starting to learning to work with LLMs. 24% are already they're already boosting their productivity with AI co-pilots. 33%, which is a good number, I think, from the audience perspective, they're already building AI agents and Gen AI apps. And the 8%, I would say somebody who's advanced on the AI curve, they're working with advanced ML and deep ML models as well. So I would say like there's an equal split, somebody who is starting, somebody who's in the early start, somebody in the middle, and very few in the latter half of the curve so far. Folks, the poll will be on. It will help us understand you better and help us curate our sessions going forward better. For example, if we see like a lot of people who are joining these sessions are already working with advanced ML and deep ML models, then it will help us move our positioning of these master classes towards more advanced topics or towards more advanced demos. So these help us curate our sessions. So just to respond to this, now I'll be out of your way. Ahmed, over to you. Let me know if you need me.
Okay.
Thank you so much. By the way, I'll just give you a very quick check. I can see your screen. Give me a quick hello or something. I can let you know that I can hear you.
Video is good.
We can hear you.
Okay,
That's
awesome.
thank you
Thanks for
so
the confirmation. Okay,
much.
cool.
Off camera and off mic.
Thank you. Thanks, Rohan, for the intro, and thanks everyone for joining. As Rohan mentioned, I work as an ML engineer at Google. I spend most of my time building applied ML systems, which means I do not focus anymore on the theory or on the research. Instead, I focus on building something that can be deployed and seen by the users. Uh, Before that, I spent some time in academia doing the regular academia things, which is teaching and doing research in ML. So, my goal of today's session is walking you through the steps, the typical steps to build end-to-end ML system or AI system with the focus on Gen AI systems. Um, my main objective is giving you some like insights on the practical sides and highlighting the fact that building AI systems or ML systems takes more than just building a model. So you can see that we have list of steps that typically people go through when they build an end-to-end production-ready system that serves like or uses ML or AI or Gen AI. Typically, we start with the problem statement or the problem definition, which usually comes from the product team. And then we do a little bit of engineering work to scope down the work. That helps us specify the features, specify which model we will use, and also it will also help like dividing the work between different sub teams if you are in a position to choose which team will do what. And then you basically identify the key components, you build them, and then you spend some effort and some time on the operations. You think through how can I maintain this model, how can I monitor it, if something goes wrong, what I should be doing. And typically also you should be thinking about some of the privacy and compliance issues because the data, the system will use user-generated content, which have some regulations, especially in the EU, for example. So let's go through these steps using an example. Again, like the main goal is not mastering this specific problem, but just using it as a concrete example rather than listing the steps in a very abstract way. Um, few disclaimer or few points that I mentioned, but I want to reiterate on them. The focus is on building end-to-end ML systems or AI systems. It's not building an ML model alone. So we're not talking only about how to achieve the highest quality, but it's in addition to achieving the highest quality for the model, we are talking about building an end-to-end system. So think about it as like a product team that wants to launch a feature or a system or a product that uses ML. That's the main goal, or think of this as like an ML engineer rather than a research scientist. The basically the non goals are not, we're not going to basically do a deep dive into specific model. We're not going to focus on a single problem. Instead, the goal will be providing the general idea or the general framework that you can use to solve any or to build any ML system or AI system. Of course, the details can vary from one project to the other. So I want to get people's thoughts on what is the first thing that you would do. Let's say that you're an ML engineer working in any company and you have a project, like your product manager asked you to work on a specific project that will use AI and ML. what are the first thing that you will do? If you have access to the chat, share with me. What will be the first thing that you will do as an ML engineer lead who's responsible for a team and you have been handed a specific problem statement? Right, requirement gathering, asking about the data. That's great. Requirements plus proof of concept, data sources. What kind of data do we receive? Look at the problem statement, understand the data. Okay, great. I'm very glad that almost everyone, use case details. This is a really good point. Uh, Understand the requirements, SLAs, and budget and MVP and risks. Collecting the requirements. Use case, user and output format. Yep, this is really great. And I'm very glad that almost everyone did not make the classical mistake, which is jumping directly to the ML modeling part. This is a very common mistake that people do. I'm very glad that no one mentioned this. But I have seen this happening where people immediately jump into the modeling details, saying like, I will use this specific model or that specific model. This actually will anchor you on like small details, and it will be very easy for you to lose track of the main objective. So usually, as everyone has mentioned, you start with the business or engineering problem as your north star objective or your north star goal, and you move backward from there. Basically, asking the question: given this goal, and we will walk through a specific problem, but given this goal, how can ML or AI help me? This will that will help you set up the right ML problem. And what I mean by setting up the right ML problem is determining the objective of the ML problem, or how are you going to use ML. ML is a black. You can think of it as as a black box that you train it in a specific way and it achieves that goal. But you need to define the goal in the first hand. You need to know exactly what you want from this ML or this specific AI component. So that's basically the important step, or the important scoping that you should be doing initially, identifying the business or engineering problem, and you move backward from there. So this is typically the case for regular or classical machine learning. But since we are talking today about Gen AI specifically, or building systems that use Gen AI, we will also introduce few concepts that maybe folks are already familiar with. More specifically, we're going to talk, in addition to just the regular process, we're going to talk about what is retrieval augmented generation. If anyone is not familiar with that, we're going to talk about different prompting techniques and different, or something more advanced, which is tool calling. So these are the things that may be new for some of the folks related to the GenAI space. Okay, so let's look at a specific problem statement that we're going to use as an example, and talk about how to build a system that solves this business problem. So basically, the business problem that is given to us, it could be given to us by leadership, or it could be given to us by product managers, which is basically design a system that generates personalized health and wellness articles for users in real time using GenAI. Let's see. Okay. So basically, one thing that I'm hoping that people can see is that the problem that is given to us doesn't specifically tell us which models should be used, or it doesn't specifically tell us what are the exact ML problem. It's more about like for the product angle. It's basically describing what we want to have from a product perspective, and it's on us to define or scope the problem down a little bit. So the first thing that you would start with is scoping the problem a little bit for the engineering team to work on it. And what would be the first step that you would do to scope the problem to come up with the engineering requirements? So if this problem statement is given to you, and we asked you to scope the problem, what specifically would you do? Understand the metrics. This is a really good point. So basically, understanding what are the success criteria, right? This is one thing. Yes. Um, Success factors. Yes. Who are the users? Really good point. Who's going to use the system, and how they're going to use it? Populations of the users. Yes. Minimum viable product. Yes. Let's see. What kind of enough data set collected, building RAG is in either real time or batch. So this is really great. High level architecture, yes. So there are many things that you can do. Different people will take different approaches. In my case, if I were to solve this problem, the first question that I will be asking, many great answers, but one of these approaches would be something like, let's see, um, okay. So basically, I will ask myself, what are the inputs to the system? What exactly do we have as inputs that we need to consider to generate these articles? And what will be the outputs as well? So, what do you folks think? What would be the inputs to the system? There are some questions people asking. Where are the answers that people are giving? People are giving the answers in the chat, and it's only visible to me so that people get a time to think about the problem, right? Like if everyone sees the answers, they will not get a chance to think through the problem. User query, articles, user profile, yes, user demographics information, user health data. Yep. Okay. So basically, you can think of it as an input in addition to the historical or the basically the ground truth or the articles, the health articles that will be given to you. You also have as an input the user profile or preference and the user question. These are the things that you will get as an input, and you have to figure out how to use them in addition to the some of the health articles, right? This is something that we should have mentioned here. Health articles that can come from different sources, right? They can come from WebMD or any scientific articles or any basically ground truth data that you have that describes some of the health data. So this is basically the inputs, the user profile, plus a user question. And the other question that we should be asking ourselves is, what are the output, which is quite straightforward that we can get from the problem statement, which is basically personalized, medically reliable articles that is based on some of the health articles, basically based on health articles that can come from like WebMD or any trusted sources. So basically, this is the problem statement that we have. Anything that we have missed? Anything else like in the requirements or the scoping of the problem did we miss? Let's see. Regulations, yes, which is more related to the security and compliance. Um, let's see. The compliant, HIPAA compliant risks, yes. How are we storing the data? Yeah, these are all details on the design itself. I was looking more on the requirements. There are some of the non-functional requirements, which is basically related more to constraints, like do we have what is the latency budget that we have, do we have like basically guardrails to be implemented. So basically you should be thinking also about the non-functional requirements. You can think of these as non-functional requirements, right? So basically, for this problem, I'm keeping like a small list of non-functional requirements, but people have mentioned tons of other things related to the regulations. You can think about uh, high availability. You can think about which hardware is available to us. You can add so many things, but just to give you an example of what could be non-functional requirements that will impact our model choices. So basically, at that point, of course, this is like oversimplification. You can add more details later, but this is a general idea about like how you can scope the problem. Then the next step that you would do is basically identifying key components in your system. Um, Basically, what you want to do is having a high level understanding of the architecture of the system. Once you have identified the inputs and the outputs, you're going to basically do a sketching and saying like, these are the components that I will have in my system. Since this is a clearly a Gen AI design or Gen AI system, what would be the main components in that system? Like, if you think it through, what would be the main components that we're going to use? Obviously, everyone mentioned that it's going to be the most important component that's going to be there is an LLM. So the question that I have is an LLM alone enough or not? Can we just use an LLM and that will be it? Okay, but tons of nodes, which is great. So basically, obviously, it's not going to be enough. Why? Why LLM alone is not going to be enough? Yes, because we need it's stateless. It doesn't know the data that we have. Yes, so it's basically there are like many examples that you can think of. But basically, if I ask it a question that says my blood pressure is blah blah blah, is that bad or not? Or I have these symptoms, is that good or not? An LLM may know the answer, but we don't want to rely on that. Remember, when we talked about the specifications, we explicitly mentioned that we need the answers to be factually correct. We need the answers to be grounded into the data sets that we have. So basically, we don't want the LLM to hallucinate, and we want to ground this to the data set that we already have access to. So, how do we solve this problem? What are the options? I know that there are multiple options. Folks are already familiar with the most famous one. But what are the options to solve this problem? We have data set, we have an LLM, we want to use that LLM to influence, sorry, we want to use this data set to influence the choices or the answers of the LLM. Yes, some folks mentioned retrieval augmented generation, some folks mentioned fine tuning, which is basically using tools as well. So we're going to talk about the three things: fine tuning, we're going to talk about retrieval augmented generation, and then finally we're going to talk about tool usage, and then we will talk about the compliance and the operations side. So, what is fine tuning? Let's start with fine tuning. What is it? In one sentence, anyone has any idea about what is fine tuning? It's not retraining from scratch. Some folks are saying like retraining the model. Yeah, I like this answer, like, which is refining the model or updating the model or adapting it to a new domain. So basically, the idea of fine tuning is you have a model that is trained to do generic tasks, right? So it's a pre-trained model. You can take like a llama model, for example, and then you add your own data set that is customized for that specific domain, and then you come up with a customized model. You can think of it as this model as a student that just finished undergrad, and then basically this is getting a graduate degree, basically specializing in a niche domain, which is basically doing a master's degree or a PhD degree, and then you get a very specialized model. So it's basically not forgetting what you have learned in the past. You build on top of that, and you get like all the experience plus a niche domain. What are the problems with the fine tuning? Why not just use fine tuning and do it? What are the main problems with fine tuning? It's expensive. It takes time. It takes effort. It takes compute resources. Catastrophic forgetting. Yes, thanks for mentioning this. Catastrophic forgetting happens when basically the model forgets this model, this customized model, forgets this and only remembers that, which is basically forgets everything that the student learned in undergrad and only remembers things that they learned in the master's or the PhD degree. It happens, and you have to be very careful where you're fine tuning the model. So it's expensive. There's a risk of forgetting, catastrophic forgetting, and also you need to retrain this for each subtask. For each new task, you need to repeat that process. So basically, there are some challenges, and it takes a bit of time and effort. And at this point, everyone knows what are the alternatives. Basically, we're having like two ends of the spectrum. You basically use the model as is, which doesn't understand anything about your domain specific information. On the other end of the spectrum, you fine tune the model or you train it from scratch, which takes a bit of time and effort and experience. Requires machine learning engineers with enough experience to do this properly. And the thing that comes in between is basically retrieval augmented generation, which provides a model the additional data at inference time. And this is the key thing here, that we are not going to provide the model this data at the training time or at fine-tuning time. We're just going to keep the model. We're going to use the model as is, but we're just going to provide it the additional information that we want the model to learn about it at the inference time. And this is done using RAG or tool usage, tool calling. It's called tool calling. So these are the two alternatives that we're going to talk about, which are potentially much cheaper. Since these are being done at the inference time, it's relatively easier, cheaper, and it can scale for multiple use cases. Okay, so we're going to talk about these two alternatives in the next maybe 15 minutes or so, and then we will talk about the operations side of the problem. Let's see if we have a question. Is tool calling the same as agentic system? Yes, it is. Inference time means once the system has been deployed and it's used by the users. Once the user types the question, clicks enter, we dynamically retrieve parts of the relevant information and add it as an input to the model. So it's not like it's not something that happens before we launch the system. We launch the system with the pre-trained model, and then we pull the relevant context on the fly. So let me show you how a RAG system will look like, and while we're doing this, I will explain exactly what I mean by inference time. If we have another question. How much percentage of query to GenAI comes from RAG versus difference between RAG and tool calling? I will talk about the difference between RAG and tool calling. So let's start with retrieval augmented generation, and then we can talk about tool calling, and then I can take more questions toward the end. Okay, so retrieval augmented generation in a very high level looks as simple as this, where basically this is at inference time, or in production, basically in production, where you basically get a question from the user. Can be in whatever domain, and then you have your pre-trained model. So we didn't fine-tune the model, we just used the model as is. And we have our data set that we initially tried to fine-tune the model on them, and then we said, like, this is so much work, let's do something much simpler. And then basically, as we receive the user question, we are going to pull the relevant information from that data set conditioned on the user question. So it's the relevant information will be pulled in real time based on the user question, and it will be fed to the LLM in addition to some other things in the prompt. So this basically gives us two benefits: that we showed the model the missing information that it's not aware of, and also it didn't require pre-training the model or fine-tuning. Sorry, it didn't require fine-tuning the model from scratch or even fine-tuning it. I know that this is high level, so we're going to zoom in into each of these components. So let's look at a zoomed in version of this figure, where basically everything starts once the user passes a question saying, I have these symptoms, what are the conditions that I have? And then basically the question goes into some storage system. So basically you can think of this as a storage system, some database. We will talk about this. So it's some database that encapsulates the data that we have. And then based off of that, it will return the relevant document conditioned on user query. So for example, like if the user is saying that my blood pressure is too high, what are the root causes of this? And then we have like thousands, let's say that we have 10,000 medical documents. Out of these 10,000 medical documents, 2 or 3, or let's say 100 documents or 10 documents are related to high blood pressure. Then this component of the system will return only the 10 relevant documents, and then it will return them to us. Now we have filtered and kept only the relevant documents that are potentially contain the answer, and then we're going to feed this to the LLM through what we are calling the augmented prompt. Okay, so basically it's a two-step process. First, we load or retrieve the relevant documents or resources or content that is related to the user question, and then we're going to feed this to the LLM. So we're going to dig deeper into these two components. First, how do we store the data and how do we retrieve them? And then we're going to talk about how do we actually construct the data and send it to the LLM. Let's see if we have questions. Let's see. What you are sharing is the naive RAG approach. Could you please share some of the more advanced RAG system that you have worked on? I will talk about tool usage. I don't think everyone is familiar with this, so that's why we're giving this basic foundation to everyone. Can you shed some light on LLM plus RAG based on your experience at work? I know it works in general, but there are significant accuracy issues. What are your views on this? So basically, the bottleneck in RAG, I agree with you that there are issues that happen, many quality issues. In my opinion, this is the bottleneck here. Retrieving the relevant information is the bottleneck, and that's I think the right way to do it is using tools rather than relying only on RAG, because this is a real bottleneck. You're using very limited models, set of limited models to retrieve the relevant information, which limits the capacity of the system. Let's see. What happen if the documents change? You have to rebuild the index. Let's see. Did the LLM get the original query and the 10 documents data refined data simultaneously? Yes. So everything feeds into this augmented prompt, which is basically consists of the user question, some instructions to the LLM saying like you are supposed to answer this question based on this information, and then basically the relevant information. Realistically, it's not 10 documents. This is too much. We basically have like shorter content that should fit into the LLM context. Okay, can you explain how ingest works? Yes, I'm gonna explain this in a minute. Let's see. The RAG approach can be used for any model. Where is this vector store? I will explain the vector store in a moment. Okay, so let's explain. Actually what happens here inside this box, because I'm seeing some of the questions. So let's dig deeper into this and see how we can store the data. So how do you think we can store this data? So basically, we need the data to be stored in that vector store. I'm calling it vector store. I'll explain in a minute why we're calling it vector store. But basically, we need to store the relevant or all the candidate documents in some storage system so that we can retrieve the relevant information, the document that are very relevant to the user query. How can we store these information? What do you folks think? Let's see. How can we store these information? Right. So basically, as many folks have mentioned, the requirements that we have, or the goal or the objective, is returning the documents or the text content that is very similar to the user question, but the similarity should be based on the semantics. For example, the word car and the word vehicle should be considered equal, even though they are not sharing any text or any letters between them. Of course, this is a toy example. The more realistic example would be I have these symptoms. What are the root cause? And someone else lists the same symptoms by saying like, I feel like 1, 2, 3. What are the root cause? These two should be considered the same, even if I'm using different wording. So the retrieval process should depend on the semantics of the original text and the query, not on the exact wording. And relying on the raw text will not give us this. If we use any type of SQL or NoSQL storage, we will not be able to get the semantics. That's why we need to use embeddings. We need to use embeddings, which is basically a semantic representation of the original text. So basically, embeddings are like, you can think of the embedding as some representation of the original text that captures the meaning. So, for example, a word like New York and another word like Paris should have similar representation or very close representation, because both of them represent major cities. The same for the word animal and horse. They should be very close to each other because both of them represent the same concept, which is an animal, right? On the other hand, the word New York and animal should have like too far representation that are not similar to each other because they represent very different concepts. The same for Paris and horse. And this is what embedding does, which is conceptually you can think of it as representing this word or this text. The text can be word or a sentence or paragraph, representing this using a sequence of numbers, which we call vector, because an array of numbers, you can call them vector. Even C++, you call them vector. Mathematically, they are defined as vectors. And these numbers represent the concept or the semantics of this word. And the similarity between these two will be high similarity. And the similarity between these two will be high. And the similarity between these two will be low because they represent different concepts. So this allows us to basically capture the meaning of the strings or the text, ingest them in some storage system that stores these vectors. So basically our storage will look like this, which happens before we launch the system. So basically what happens is this stage happens offline before launching the system. And basically what happens is, in detail, is that basically we have the documents. These are the documents. Sorry, the docs. And this happens offline, which means before launching the system. We run these through an embedding model, which is the model that converts. This is the embedding model, which is different than the LLM. It's not the same model as the LLM. It's a completely different model in terms of the size and the architecture and what it's supposed to be doing. Here, this is a toy example. We have only 3 documents, and the output will be 3 vectors, one vector that represent each document. There are some nuances here that I'm skipping just to skip the details. And then basically, the outputs are ingested and stored in that vector database. It's a special type of databases that stores 2 things. It stores the original documents, the original text, and the associated embeddings. So you can think of these as key value store. They are not key value store, but you can think of them as key value store. The key is basically the embeddings, and the values are the original text. And then at inference time, when we deploy the model and we get a question from the user here, the question goes all the way to the vector store, and now it is the responsibility of the vector store to say, like, these are the most relevant documents. And the way it does this is by also converting the user question into the same embedding representation using the same model. So these 2 models are the same, and they are completely different than the LLM. And then it uses these embeddings, matches them, computes the similarity between the query embedding and all the candidate embeddings, and it says, like, maybe this is the closest one, so this is the most semantically similar document or representation of a document to the user, to the user's questions. Of course, we can return the top document, top 2 documents, top 3 documents, or more generically, the top K documents that basically we return them to the user. Okay. So one question that people asks, what is KNN? KNN is K nearest neighbor, which is basically saying that I will return the K. K can be 1, 2, 3, 4, whatever number you want to choose, closest documents to the user question. So basically, based on the embeddings, if we compute the distance between this vector and that vector, there is a closed formula you can use to compute the distance between, or the similarity between 2 vectors. Based on that, you're going to say, like, out of 100 documents, the top 3 only will be returned. So basically, the way you can think of it is, for simplicity, you can say that we're going to do linear scanning. If we have 1,000 representation of the documents, we are going to run 1,000 comparisons, have 1,000 similarity score, and only return the top 10 documents, the one that are closest to the user query. In reality, the linear scanning doesn't happen because it's slow. There are some approximation algorithms that run, but we don't have to worry about this for introduction. But at least conceptually, you can think of it this way. So basically, the vector store stores the embeddings, which is a vector representation of the original document, and allows us to query these documents using the representation of the user query. Okay. What are the popular embedding models? The most popular one is BERT embedding. Also, OpenAI has its own embedding models. BERT is a family of models. There are multiple variations of these, so that these are pretty much what everyone uses. Does the accuracy change if the vector-based search based on KNN is used? Yes. So if you use different BERT embeddings, if you use different K, then definitely the accuracy, the end-to-end accuracy of the system will change. Famous vector store examples are Weaviate. Hopefully, I'm writing this right. Weaviate, Qgent, Chroma. There are many, but these are the top three that I can think of. Different examples. Pinecone, yes, thanks. Pinecone, that's correct. There are many examples. You can Google these, but I think this should be enough for getting you started. Different embedding models before storing into a vector store. When we query, how does the system knows which model is used to search the database? Good question. So the question is saying, how do we enforce that these two models are the same? This happens within the vector store. So you use the vector store as a bundle, and you say, like, create a vector store instance with this embedding model, and then you use the same thing for offline and online. You can shoot yourself in the foot by using different models, but like you should be structuring your implementation to not do this. Do you have to use the same embedding as the LLM? The embedding model is completely different than the LLM. You cannot use the same, actually, because the embedding model produces embeddings and the LLM produces text. So you cannot actually use them, and you have to use different models. Okay, cool. So I have one question for folks. Based on your understanding of the vector store, what are if you look at the vector store as a black box, what are the type of the return results here? So the output here is what? Like, if you think of this as a data structure, what is exactly the type of the output that is being returned? Okay, so it's a split between the correct answer and the wrong answer. Some folks are saying this should be text. Some folks are saying it should be embeddings. Actually, it should return a text, not embeddings. And the reason we need text is, remember, how do we use this whole black box? This whole black box is supposed to return relevant documents, not embeddings. The embeddings that are generated internally are, you can think of them as implementation details within the vector store, rather than like something that should be exposed. So the whole point of that vector store is basically returning the relevant documents as text instead of returning the embeddings. Internally, it uses embeddings to find the closest documents, but that's basically internal implementation details, rather than be exposing this and returning it to the LLM. Because remember that the LLM, what is the input to the LLM, by the way? Like, what do we feed the LLM? What are basically the input to the LLM? Text, right? There are some multimodal models that take images as inputs, but let's not worry about that. Yes, it takes a prompt, which is text, which means if the vector store returns embeddings, then the LLM will not be able to handle this or to deal with it. So basically, we have to make sure that we're returning text, and the vector store is capable of returning text because it stores the associations between the original text and its embedding. So it can easily, you can think of this as the key, and you can think of this as the value, and then it matches the query based on the key, and then basically it returns the values associated with them. Let's take some questions from the Q&A tab just to make sure that people are following me. So the embedding model is essentially the human who identifies the similarity and relevant information. If you make an analogy, then yes, if it's an analogy, but of course it's not a manual process. Let's see. There are some answers here, so I'm just going through these to distinguish between the answers and the questions. How are images handled in articles? Really good question. To handle images, you can do few things. The easiest, not accurate approach is generating captions of images using different model and ingest these captions. or you should be using actually multimodal embeddings and multimodal LLMs. Multimodal embeddings are basically models here that can consume text and or images and generate representation using these. So there are multimodal embeddings, and most of the LLMs are also multimodal. The embedding seems very important part in finding good matches. Can one train that model to perform better? Yes, you can fine tune a model on your domain, but I will tell you something that it's almost always going to be a bottleneck for your retrieval because it's very limited compared to the LLM. So basically, this LLM is a much bigger and more capable and powerful model compared to any embedding model that you're going to use here, because this embedding model has to be lightweight because it processes huge amount of data. Um, how are embedding models trained so that they can capture the semantics effectively? That's a bit of like a long topic, but they are basically trained on a huge amount of text, and they learn the association between these two different texts that represent the same meaning, but using different wordings. But it's a bit of like a long topic. I would recommend reading a little bit through BERT embeddings to get an idea about that. Can we use multiple embedding models for more refined results? You can use them independent of each other. So basically, you cannot use a model here and use a different model there, but you can use multiple models and then you fuse the results eventually. So basically, you can conceptually use multiple vector stores and merge the ranked result. I haven't seen this done, to be honest, but this is something that you can do. Another thing that QGen supports, which is a type of vector store, is hybrid search. It supports searching using embeddings and keywords, keyword matching, because some use cases you want to prioritize keyword matching. So some of the vector databases support that. Can numbers be vectorized, or does it work only for words? It works for text. So if you want to parse your numbers as text, you can do that. Can I replace the entire vector store with simple search engine results? That would be tool call. This is a really good point. Yes, you can do this, and this will be tool call, which is a really good segue to my next topic. So basically here, what we have been doing is limiting our LLM to exactly one source, right? We are saying that we are going to use exactly one source, which is the vector store, right? Everything has to fit into that vector store, and we are going to use that. This can lead to some limitations. Can you think of why this is not ideal? What are the limitations that we can have? If we say like LLM, it can only use answer that is on the vector store. Outdated data. Yes, this is one problem. What else? Uh, some issues related to recovery and if the database is down, but yes, no live updates information. This is really good point. Yes, examples of this, when you ask, like when if you open ChatGPT or Gemini and you ask it about recent events, it seems to be able to recognize these events, right? It knows what you're talking about. There's no way you would be able to basically update that vector store with that frequency almost every minute to keep up with the recent information. This is a really good point. Question outside the vector will not return answers and relevant. Yeah, okay. So I think there are multiple limitations. The one about the recent information is one of the problems. The other problem is also related to not everything will be answered with one source. It can be actually answered by multiple sources. Search engine, as the example that someone mentioned, getting the recent weather. Like if you are asking it, I'm traveling to Paris, should I get an umbrella or not? This requires multiple APIs, multiple sources of data. So people came up with this idea of saying, let's allow the LM, or let's give the LM the option to choose between different data sources. And people coined the term tools. So when people say tools, they are actually talking about APIs. So you can conceptually think of tools as something equivalent to API calls, which is basically allowing, what will be the case if we allow the LLM to call some tools based on the user question. So we show the LLM the user question, and we show it the list of tools or APIs that it can call, and we ask it, what are the APIs that you can call, or what do you think the right API that should be called? Yes, this is APIs or functions. This is the same, conceptually the same thing. It's basically API tool or function to, sorry, API call or function call. Let's see. Okay. So basically, this is the main idea of adding or allowing the LLM to call APIs or tools. People refer to this as agents. But before we talk about agents, I have one question. What do we actually mean when we say LLMs calling tools or calling APIs or calling functions? Can actually LLMs do this? Is this something the LLM can do? Let's see. I'm getting no's and yeses. The LLM itself cannot call the tool directly because remember, LLMs take text as an input and produces text as an output, right? So all what the LLM can do is parsing some text and producing some text, right? So how can we solve this problem? The way around this is building, yes, what everyone has been calling on the chat is building agents. So the agents are basically LLMs plus some code around it that makes it feasible or doable for the LLM to call these APIs or to call tools. So what happens in reality is that you get a user question. The user question is received by your backend. You have a literally backend that you can implement in Python, C++, Java, whatever programming language you choose. The backend will take that question, forward that to the LLM. Of course, there are tons of prompting techniques that happen, but we don't have the time to talk about all of these. But there are some prompt plus some prompt here. And basically, the LLM returns the name of the tool that should be called. Actually, the prompt here contains the name of the available APIs or available functions that can be called. And based off of that, the LLM says like, okay, the search tool is the most relevant tool, or the weather tool is the most relevant tool, or tool number X or tool number Y is the most relevant tool. And now the backend, and it also returns plus the parameters that should be sent to this tool or to this API or to this function. Now the LLM, you can think of the LLM as doing reasoning here. It's not only used for generating the final response, but it's also used to do reasoning or planning that this question needs to call this specific API. So this is basically what people refer to as reasoning or planning. Okay. And then basically the backend takes the name of the tool. This is now Python code or Java or C++ code, so it can call an API or it can call a function. That's doable at this point. It takes the response from that tool and forward that back to the LLM. And then the LLM makes another decision whether it has all the information needed or it actually needs to make another API call or another tool call. And then it does this by repeating steps from 1 to 5. These gets repeated in what people call reasoning loop. So you can see here that we are not only using the LLM to just give us a final answer, but we're also using it to determine what are the tools or what are the APIs or what are the functions that are needed, which is an extension of what we have to what we had in RAG or Retrieval Augmented Generation. In Retrieval Augmented Generation, we were kind of limiting ourselves to only one source that has to be used in one specific way, and we have made that decision upfront. Instead, here we are repeating a number of steps to pull conditional information from different tools. It's not a single tool, it's multiple tools that the LM can use in whatever order it has decided or reasoned about. I'm going to stop here because Rohan has an announcement, and I will take that time to answer some of the questions offline.
Ahmed, will you be taking the next part straight away, right after this?
Sorry, go ahead, one more
And
time.
there's another section of yours which is left around, I think, privacy concerns and everything.
You
That
want
will
me to
be
give
after
it?
this. And is there any demo involved?
There's no demos. Yeah, there
Got
are
it.
no
Yeah,
demos.
I just want to be clear. Folks, I'll sorry for this break. I just want to have like a very quick announcement. Then, by the way, the race, it's not sure, it's not stopped. There's still content. There's just like one very quick announcement I want to make. Can I share my screen, Ahmed, if it's okay? It's not going to take more than a minute,
Go
folks,
for
by the way.
it.
This is regarding a thing that we're launching. So I thought I might as well walk you folks through it. There are two events. Don't just simply respond to the poll. I launched the poll. One is there's a next Masters on 30th of September. It's with Nahid Farhadi. She is working it currently at Microsoft, ex Google, and it will be around demystifying LLMs, how to choose the right model. I think it was very much relevant to the current session. Hence, I thought I'll just quickly break the flow. Sorry for that again, but just simply share with you if you folks are interested in this. This is one. Second is something which I'm really excited to share with you. Again, it's in the works. I'm just sharing like a Google Sheet version of it. Sorry for that. There's an AI Launchpad event which we are hosting from 10th to 12th of October. It will help you set the right foundation. Again, it's free of cost. It's free to register. I'm just hiding the instructor name because like still in the preliminary phases, but the topics, timing, and everything is finalized. Um, it will start on 10th of October, around 4:30 p.m. PST. It's a 3-day workshop, 3-day boot camp, whatever you want to call it. First, we'll set the foundations of AI and agentic AI. Then the next day, it would be around demystifying LLMs and choosing the right model. Then on 11th of October, after the foundations have been set, 11th of October, we'll build the first AI agent. Then after having built the first AI agent, then we'll move to designing multi-agent workflows. And then the final day when we'll wrap it up, which is on 12th of October, that is Sunday, there will be a masterclass on from demos to deployments. How do you deploy real world agents? And then there will be an AMA with FAANG plus instructors. There would be a panel of 4 to 5 instructors, or maybe 2 to 3. I'm still not sure about the number, how many confirmed yeses, but at least 2 instructors would be there, or 2 subject matter experts would be there to take questions. How is the industry shaping? Your industry specific question, I'd be happy to address. So just wanted to break the flow for this. I'm so sorry. There are two things lined up. One is on 30th of September, which is the next masterclass around how do you choose the right model for your projects or for whatever use cases you're dealing with. And second is the AI Launchpad. The poll is live. I see that 255 watt folks. If it's a yes, if it's a no, do drop in a yes or a no. That would be super helpful to know. We'll be happy to send you the invites for the same. Over to you, Ahmed. I'm so sorry to break your flow like this, but folks, I'll keep the poll live for the next 5 minutes. Feel free to respond it. If it's not visible, it's under more section on your mobile phones or on your Zoom desk. If you're using Zoom on desktop, sometimes poll option is not really visible. And don't respond on chat, please. There are a lot of people who are saying yes. And also, by the way, Jeff, it does take lesser amount of time. It's just a very small boot camp to help people understand what agentic AI is if you're early in the journey, and then give you a few demos around the agents. And it's like an interesting thing that we are baking up over here. Over to you, Ahmed. I'm so sorry for this
No
interruption.
worries.
Thank you so much
Please.
for understanding.
No worries. Folks, for the questions, please put the questions in the Q&A, because the Q&A tab, because it's so easy for me to miss the questions in the chat. Like, it's, I don't know which questions I have answered and which ones I haven't answered it on the chat. If you put it in the Q&A, it will be easier for me to manage that, because maybe I will take some time towards the end to do that. So let me share my screen one more time. But please, if you have a question that I haven't answered yet, put it in the Q&A. I'll spend some time towards the end answering these questions. So basically, the idea again for agents is that, of course, like I'm abstracting some of the details because of the time constraints, but basically the idea is allowing the LLM to choose between different tools. And again, we talked about tools as APIs or functions that the LLM can choose. And basically, the LLM has been trained in the pre-training stage to see the input questions, and based on dynamic list of tools that are determined at runtime. Keep in mind that here, this LLM can be an LLM that you do not own at all. It can be basically an LLM from OpenAI, like 4.0 or 4.0 mini, or it could be Gemini, or it could be Llama, could be any LLM. And then you feed to it the list of tools that are available at the inference time when the user submits the question. And then basically you ask it, what are the name of the tool that you think should be called? That's basically the idea. And it tells or returns to you the name of that tool. It doesn't call the tool, it just tells you you should be calling this tool with these parameters, and then the backend will call the tool. And then it returns the results for the LM with the full context saying, like, this is the original user question. You asked me to call this tool. Here is the output. What should we do next? And basically, at this point, we are relying on the LM as a reasoning engine or a planner to tell us what we should be doing next. Of course, there are many issues that can happen in this scenario. What are the issues that you can anticipate? Other than hallucination, one problem is this loop can run forever, right? Or it can run for a really long time, which may exceed our latency budget that we allocated. Maybe if we have like an SLO of answering questions within 20 seconds or whatever, like it can run out of this latency budget. Usually, the number of reasoning iterations are enforced by the backend, which this is why the backend is extremely important. It is the piece of software that you build as an ML engineer or as a back-end engineer, and you enforce the business rules or the business logic here. So basically, this whole thing people refer to as an agent, which is basically your LLM plus tools plus the code to call these LLMs and these tools and orchestrator, and it is the internal memory that is kept on the server because the LLM is stateless. So that whole thing, you can think of it loosely as an agent. Okay, so of course there are some details that I didn't get the chance to go through them, but this should give you like a generic or a general idea about the key components in building this GenAI system. Now, your job is not done once you have launched this thing. Uh, Many things need to be done. So what? Let's say that we built that system, we took care of the small details, and we launched it. What can happen? What do we need to do after we launch the system? What do you folks think? We have to monitor the system. Yes. Uh, yes, great point. We have to deploy the model and then monitor the system for accuracy. Let's say that the accuracy dropped. What we're gonna do? Or a drift happen? Yes, some folks are mentioning there's potentially a drift. Yes, we are going to either update the model or update the prompt or update the vector store or update all of these, right? So basically, you have to think about the operations and how painful it is or how easy it is to update the system or to update components of the system. So things can actually get like messy quite easy. And these are some of the things that I have seen like maybe a year or a year and a half ago, where we started initially with this simple setup and we said, okay, everything is in place. And when we started updating the model and or the prompt, we realized quickly that although we have to have like some kind of versioning because these two have to be consistent. Like a prompt is tailored for a specific model version, and if you change the model version, you may need to have a new prompt. And what happened if you roll back one of them and you didn't roll back the other one? My point is, you should think of these two things, the prompt and the model, as a bundle. If you roll them forward, you roll them forward together. If you roll them back, you roll them back together. So that basically requires some kind of a versioning system, which gets a little bit into the ML ops. Like, you should think about how can I build versioning system that allows a team of 10, 15 engineer to roll forward models or roll back models. Very similar to server releases, right? You do not rely on people remembering which version was used for that feature. You basically use proper versioning systems. You use proper system releases. You use proper rollback and roll forward. The same happens for any GenAI systems, but there are a little bit more complications because we have so many moving parts. This is the first part that I wanted to highlight. The other thing is, let's say that you changed that bundle that you versioned. How would you know whether the system is doing what it's supposed to be doing or not? You have to have like proper monitoring. You need to have what people refer to as online monitoring, which basically relies on the how the system is performing in production, regardless of what exactly the model that you have. So you should be relying on some of the user metrics or the impact on the user. You can define this, which depends really on the problem that you have. But basically, it should be independent of your model. It should be basically measuring the impact on the end user. You can take a proxy to this, which is basically the number of active users or number of turns. Basically, do people ask follow-up questions because they think you are giving them useful answers and they are asking follow-up questions, or they're abandoning all the conversation because you think your system is not giving them good answers? You can also look at containment rate, which is basically the ratio of the calls that have been answered by your system or by your model without escalating to humans. These are basically simple online metrics that you can think of, but you should basically come up with a few things that you care about, again, from product perspective, rather than only relying on the model. And you shouldn't think of online metrics as ML metrics. You should think of online metrics as product metrics. Um, this is one of the things on the operations and the versioning. The other thing that I'm going to talk about it in less than a minute, which is like way oversimplification, but we don't have enough time, is privacy, security, and compliance. It is true for all domains that touch on user data that you have to think about privacy, security, and compliances, especially if you have users from EU. But the main things that users care about is being very explicit on whether their data will be used for training or not. For the vast majority of the cases, you don't have the option to use users' data for training unless that's explicit and users have consented to that, and it's a jobs of lawyers. Of course, the health domain has some of the restrictions similar to what folks have mentioned, like HIPAA compliant and all of these things that are related to the health domain. But the generic one, or the general ones, are being very explicit on how we are using the data, whether it's for training or not. You have to have like some guarantees on the factuality, especially if you're giving people answers in sensitive domains like health or finance or something like that. People do care about biases because these models are trained on internet data, and the internet has lots of bad stuff. So you should have like some safety and safety filters, basically, to prevent your model from saying anything that's abusive or anything that can have internal biases. You should actually expect that there will be malicious actors that will try to get your model to say bad things. So think about big companies like Microsoft, Amazon, Meta, Google. If they launch, or when they launched the initial version of the virtual assistants, many people went there and tried to get these models to say bad things just to put these companies in a bad spot. So if you do not have these safety filters, you'll be causing more harm than good. Okay, so that's all the time that I had for today. There are so many things that I wish I had more time to cover, but I wanted to give you the overall summary, which is basically building ML systems is not only about building models, it's about building end-to-end systems. As an ML engineer, your job is taking care of that whole end-to-end system, or at least being aware of that. And your job doesn't end once you deploy the solution. You should monitor the system. You should think about versioning. You should think about the backward compatibility and how to release new updates. You should think about, like, as a starting point for designing new systems, you should think about data sources, data flows, and the main components in the system. Now I'm going to use some of the remaining time to answer the questions offline. I will type the answers in the Q&A, and I will let Rohan handle the remaining of the session. If you have questions for me, please put them on the Q&A tab, and I will be happy to answer these offline
And
for you.
Ahmed, would you want to take some live questions in the end? from folks.
For
If we have time, we'll take some live questions in the end.
for
Let me
sure.
quickly wrap up my section in the next 10 minutes. Then
For
folks who have questions for Ahmed, who would you want to address like live with certain follow-ups, we'll be happy to have you unmute you and have you have that conversation.
Sounds good.
I'll
Sounds good.
very quickly
In the
share my.
meantime, I will take questions on
Sure.
the Q&A, I guess.
Again, there's one piece which we have reserved for you in the end, a very small giveaway. So do stay tuned in. By the way, just a few quick clarifications. Firstly, the slides and the recordings, yes, they will be made available, but not immediately. The videos for these sessions undergo some post processing. So there will be some editing in cuts, etc. So it will take a few days' time before we make it available. This is one. Second is in terms of the earlier thing that I shared, the AI Launchpad and the masterclass. Yes, they are free of charge. There are no costs associated with it. I think a lot of you were asking this. Another piece is somebody said, will this be a code along demo sort of a thing? It will be very difficult to build something wherein you're coding along or building your agents with the instructors or subject matter experts. But what we will ensure that I'll ensure at least two things. One is that you get the GitHub repositories and everything with you, whosoever attends. And second is the slides are made immediately. Let's say 10th, 11th, 12th. The sessions get over on 12th. Post sessions, you get the slides, etc., in your inbox with the GitHub links or whatever, wherever the repositories are. You get all those deliverables immediately made available to you. So I'll ensure of that for at least this AI Launchpad week. Cool. So like I said, if you haven't responded, I'll be stopping the poll now, and be diving straight into the next part of the session, which will be like hardly 5 minutes, 10 minutes maybe, and then we can take questions from Ahmed. So folks, this part is around interview Kickstart, about what we do, about what our offerings are, and a few industry surveys that we have. It would be great if you could stay tuned. And I'll be running a poll around our offerings and consultations. After this, that you know, if you and if somebody further wants information for taking a call, yeah, I do want to speak to a program advisor or not. So Interview Kickstart is currently operational on multiple fronts. We have core three offerings. One is interview prep, second is AI upleveling, and third is B2B offerings. The core elements which are relevant for folks who are here is the interview prep and the AI upleveling. Coming to what is the market scenario, what is happening in the industry, there is something that we a lot of our research team has curated is that companies are investing like never before in AI. It is projected that there'll be around 1 trillion of investment over the next few years, with 53 billion already invested by FAANG Plus in Q1 2025. But somebody would say, like, where is this money going? Like, under what key heads are these expenses or these money being allocated to me? So the core of 50% of that allocation is under AI infrastructure. It's a fixed cost that these companies are expected to like get results out of over the next few years. Next is the model development. And then there are industry specific solutions which are being built. Second element in the current market scenario is the job openings. Again, we work very closely with the LinkedIn team. This is something which we work with them with specific POCs over there, understand what are the job openings that are being listed in on their platform. So one core piece or one core trend that has come across is that the AI ML roles have significantly rose in 2025 by almost 1.65 times. Not just that, associated roles, for example, data engineering, data science roles, they are also on the increasing side. And there is a projection that AI, ML, DSTE roles will continue to rise in the rest of 2025 as well. And not just that, we're saying there's a massive ton, there are a lot of jobs in the AI ML domain, but there's another emerging trend, which is emergence of AI preference in traditional tech roles. So let's say somebody was an engineering manager earlier, 3 years back, maybe 4 years back, but now the ML expertise or at least nuances are being asked for in the traditional tech roles as well. And that is across geos, be it in US, Canada, India, everywhere. Because of this, money is going towards AI, be it in infrastructure, be it in model deployment. The demand is increasing. There's a massive compensation gap between a traditional role versus an AI-enabled role. So, so for somebody who is an early mover on this side, he or she can make significant gains. Again, this is all based on the surveys that we have done with different industries. Like we have so many like almost 7+ instructors who are actively working with us, and with 25,000 plus alum base. All these are proprietary surveys, and then based on that, what we are seeing is in the higher senior engineering manager role, the gap is as high as 350K, and it starts from 10K on the lowest side to as high as 350K. And then there is, I would say, Zuckerberg, who sometime back was like doling money out like anything, but maybe for the right reasons. So because of this so much happening in the market, we understand there is one thing which is, what do I say? There's one, sorry, I'm just incorrectly launched a poll. I'm so sorry. There's one thing is what we are seeing is people are finding it very difficult to understand what their path is. And why that is it? Because some people have like AI is impacting their role or not, or what would the impact be? And on top of it, the impact is unequal across different roles. For example, as per current surveys, 1 in 4 software engineer roles will now seek a Gen AI expert. However, when it comes to engineering managers, the impact is on a little bit on the lower side. Almost 1 in 5 engineering managers, JDs, show AI requirement. However, if I take like a complete bucket of job descriptions out there, there are 10% new JDs across roles are now mentioning agentic AI. Uh, just 1 second. Yep. So, for people who are in have this lot of confusion, like what should they do, what should they not do, and sometimes people may already be aware. It's not that everybody has that. There's a quick poll I'm launching which will help me understand. This is something which is an internal proprietary thing. We call it the 4 stages of AI denial. Some people are saying like, why do I not need to do AI? Because I can't do it. It's moving too fast for me. Or some people have this idea like it's there's just too much out there. Some folks have this that my job is unique and safe, like it's not going to get impacted by it. And then there are people who's like, okay, let's say if I do look to up level or I do look to transition into AI, but I am, let's say, at an EM level, to get into AI I'll have to down level. Maybe they don't have to down level from the remuneration or the salary perspective, but from the role perspective they may be like, I may have to down level. And then there could be people who are already ahead on the AI curve, which is already great. So this is just a very quick poll. I'll just tell you like how where the audience currently placed. One thing that we really see is either people are saying it's too fast or there's just too much out there. They just don't know what is the right information to absorb and what is the right output to expect out of it. So if I were to say like 53% of you are saying there's just too much out there, and 30% of you are saying AI is moving too fast for you. 16% great job, kudos to you. They're already ahead on the AI curve, which is great. And there's 1%, very small fraction of people who are saying that they will have to down level if they have to move to an AI first, if they have to like transition to AI roles. So these are valid concerns, valid fears, because even if you have to transition, even if something is moving too much out there, there's some investment, be it in terms of your time, be it in terms of your money, that would be required, and you have to be careful before you take that call. I'm ending this poll. Thank you so much for response. It was like very quick thing. What we internally do is we have defined like to help you understand where are you currently on the AI curve, and we call this tool as an AIQ framework. It can help you make a call for yourself, where you currently are, and where do you need to be if you want to be somewhere else. Got it. So if I were to show you, so these are the AI up, this is the AI up leveling curve that we have built internally. So the very first part is augmentation. When you start working with LLMs, or when you start working on productivity tools with AI copilots, then comes the transformation part, where you start building complex AI agents. And then the next phase after that is you build on top of advanced ML models. And the extreme end as of today is you're starting to build complex ML models. So the first part is augmentation. The second part is transformation. Just to give you context, when we launched the poll in the very beginning, there were 33% folks to almost 66% folks were in the augmentation stage. However, what we believe internally, the major gains, everything that is going to come from this AI wave is predominantly going to be in the transformation stage, where you're building complex agents. Because I think only 33% of the folks, or 30 odd percent, said that they're already building agents, which is great. 8 to 10%, I think I remember, said that they are building on top of advanced ML models. or they're building complex models. So it's like 40% of you out there are already in the transformation phase, but maybe 60% not. So there are two paths. You may choose to want to move to the transformation phase. And the folks who are in the transformation phase, they may want to move further up the up level curve. But there are two caveats over here. The more you further move up, the time required to move up is definitely be there. The investment on top of it, be it in terms of money for courses or for the right material out there, would be required. But most importantly, time would also be there. And a one very core element is the coding element, the mathematics element. For example, the statistics and everything. Those expertise will become more and more nuanced. So maybe building complex models may not be for everybody who doesn't have that prior background, or if they're willing to put in that time, it's great. But building AI agents or building on top of advanced model is something that most of you, as per us, can aspire to reach at. Um, Coming to the next part, we don't cater to augmentation stage, by the way. Internally, we do host these master classes to where we talk about LLMs, where we talk about productivity tools, but we don't, as an as a for company, offer courses or anything related to that. Coming to the next aspect, when it comes to these, whether you're building AI agents, whether you're building something modern ML or deep ML, the next element that comes is uh, one second. Yeah. The next element that comes is, what are the different roles that you can target? If somebody is building agents or building Gen AI apps, the roles that you can target are AI software engineers, AI product managers, AI EMs, where the core idea is that there's a demand for domain expertise combined with skills. Then the next element is, if somebody is building a modern ML, who are already building on top of advanced MLs, the roles, which is a new emergence in the market, is modern ML engineers. And then the deep ML folks who are building these complex models, the roles that you can target are deep advanced ML engineers and AI researchers. And for us, we have the courses which we can help you up level or move to the next level. For somebody who wants to transform, who wants to like build complex AI agents or Gen AI apps, the course that we have internally is Edge Up. For somebody who want to building on top of advanced ML models, the course that we have is Flagship ML. And for somebody who wants to build complex models, we do have courses for them, which is Deep ML Interview Prep and Switch Advanced to ML. I'll just very quickly tell you, what does EdgeUp contain. EdgeUp has two offerings, Pro Code and Low Code. Pro Code is somebody, let's say, for software engineers who are people who are currently in IC domain, IC roles, software engineers, backend, full stack, all those folks, and who have hands-on coding experience. What comes in this course is there is a GenAI expertise that we build with you. Then there's interview prep on top of it, so that we help you move to specific roles in the specific companies that you're targeting. The duration for this is around 6 months. However, low code doesn't have enough coding requirement. This is more for people in managerial position, TPMs, product managers, engineering leaders. It is more around building agentic and Gen AI systems and leading with AI strategies. Again, it comes with interview prep and it has 6 months. So the tools will vary between the two, because some of the tools that require you to be have hands-on coding experience, and some of the tools would definitely be like low-code tools. In terms of how this whole curriculum is structured, it's a 14 to 12 weeks program, 14 plus 12 weeks program, essentially 26 weeks. Week 1 to week 2, the first 14 weeks would predominantly be around building your Gen AI expertise. The remaining 12 weeks would be around interview preparation, wherein we'll give you complete structured preparation for the roles and for the expertise that you have built. The low code one, also a similar 14 plus 12-week program. Again, if you want to get a screen grab of this, feel free to grab it. 14 plus 12 week, the first 14 weeks would be around building your expertise on the Gen AI side, building advanced agents with you. And then the remaining 15 to 26 weeks would be around interview prep. The building on top of advanced ML models, it is three courses. It's a flagship machine learning course, one of a hot selling course after EdgeUp. There's modern ML interview prep, and it helps you switch to MLE roles. It's a 9 month program. Like I said, the more you move further up the curve, the time required is higher. Over here, the core part of your curriculum would be predominantly on building your expertise. Then the remaining 2 months would be around helping you prepare for interviews so that you can transition to these roles. Over here you choose your area of areas of specialization, whether you want to work on whether you want to learn more about advanced natural language processing, whether you want to work on advanced computer vision, whether you want to work on big data and Apache Spark. But the core point being, first 7 months are helping you build your foundation, and then the remaining 2 months are more around interview prep. What happens over here is all these courses are very project centric. There will be live workshops with the coding instructors. Again, these are not like these master classes. Some people confuse it with these master classes. The master class is more about sharing our thoughts on a topic very quickly. These workshops are live, where you're interacting and building with your mentors or instructors. Then there are self-guided projects and capstone projects. So your course starts, there's a workshop, then you work on a problem statement, then there's another problem statement, and then the capstone projects get involved. Coming to the building complex ML model, this is an advanced machine learning course. It's again further higher in the duration side. It's almost a 14-month course, where in the first 1 year is focused on building your foundations, building on advanced concepts, and the last 2 months are around building for your MLA interview prep. Again, it's a project centric piece. It comes with 50 plus assignments in mini projects, and then there are capstone projects. The reason why these are project focused is because in today's time, a lot of folks in the industry are asking for your portfolios. They're asking for demonstrable AI skills rather than having a line on your resume or your CV. And the portfolios are being asked for, and that is where these things come handy, where you have industry specific projects from based on, let's say, somebody's in health tech or somebody's in consumer tech. The thing that you have worked on historically is something that you can showcase. And if somebody's already has that portfolio, great, but a lot of people don't have enough projects to showcase. That is where we come in while helping you build your expertise, but share these things or nuances on top of it. Coming to and just a very quick summary or recap. Edge Up is for somebody who wants to stay in their domain but want to be AI enabled. It would require at least 6 months of your time frame. Flagship ML course is for somebody who wants to transition to AI, and advanced ML is for somebody who wants to switch to advanced ML. Again, flagship ML and advanced ML are both sound similar, but the nuances are different. Duration requires increases as you further move down. In terms of if somebody's, let's say, is unsure, what should I do? I'm in the augmentation stage or I'm very early in the transformation stage, then Edge Up is the right course for you. Coming to the pricing, again, these are the listed prices. We have scholarships for all of the folks, but they are for certain durations. The course prices start from somewhere around 8,900 USD for Edge Up. And for flagship ML, it's somewhere around 10,500. And for advanced MLE, it's almost around 13,000. But like I said, there are scholarships on top of it. There are discounts on top of it. These are listed prices. So feel free to reach out to your program advisors. They come with money back guarantee. There is placement assistance. We help you move transition to your jobs. There is financing available, and you can enroll now and start anytime. On top of it, like I was mentioning, we have interview preparation courses as well. For example, somebody's like, hey, I already have a portfolio, I already know about how to build agents, or I'm already working on advanced complex ML models, and I just want to prepare for interview preparation. Then we have interview prep courses as well, which don't come with AI enablement. They're predominantly focused on your domains. And again, the program advisors will be happy to share information with you. Do drop in yes in the chat if you want to know more about our offerings. The poll is sorry, not in chat, on the poll. It's live. If there is you would want to know more about us. Just one last piece. I think people are more fixated around the salary increment or the output that they can get whenever they invest in any course or any tech company, and that is how a tech companies customer focused outputs are evaluated. So the typical minimum that we see in terms of salary increment is somewhere 75,000. Typical maximum is around 150K, and the maximum has been all the way up to 835K. Just to give you like a very small snippet, we bring AI that's customized for you. We have instructors from top companies and are very project focused, and the courses are built and delivered by FAANG instructors and mentors. Um, the poll is live, and also I think a lot of people you were asking about recordings and all. There's a masterclass gallery page which we are building. For previous masterclasses, the recordings are already there. For newer ones, again, we'll take some time to repurpose, edit, and put it over there. But if somebody wants to go through our earliest master classes, I think it already has around 14 odd master classes listed over there. You can scan this code. I'll share the link in chat. That would be it for me. I'll just quickly scan through the Q&A section. Is there anything relevant for me? So a lot of companies require industry experience before they hire in these domains. How do we handle this? Yes, the prior experience is needed, but demonstrable experience is equally valued, considering there's a currently mismatch in demand and supply, and we help you with referrals on that side. No undergraduate CS degree. Shiv, I think the question is how realistic is up-leveling for those with no post-grad education undergraduate computer science degree? It is possible, and I think most of our people that we have over here, not post-grads, by the way. It's not like we have folks who are PhDs or who have done their MTechs or masters in a certain tech domain. That's not the case that we are seeing internally. Um, Mohammed Mazumdar, you're interested in B2B offering to coach your whole team. I'll be happy to connect you with somebody from the B2B side. They will be happy to send you a list. I'll share my email with you. Mohammed, can you help me with what your ask is so I can let you know whether we have a relevant offering or not? I hope that works. I'm sharing my email address with you. Yeah. Coming to the next question, can you share some insights on data? Sorry, I think these are all for Ahmed. Ahmed, I think you can take over. I think we still have good 5 odd minutes if you're up for it. Over to you. We're already on time. I think I went a little bit slower than I usually do.
Sure. Yeah. Let me take some of the questions in the Q&A. I have answered some of these, but let me go real quick on the remaining ones. So there are some questions I will leave for you, Rohan, on the slides and all of these operations. Let me go through the other questions. Let's see. Sorry about that. What goes into determining what to update during monitoring? Can you expand? This usually involves evaluating different subcomponents of the system. So, for example, if you have a vector store and an LLM, you need to evaluate the LLM alone and you need to evaluate the vector store alone so that you can get an idea about the root cause of any quality drops. Do we have versioning of the whole agent? Usually, I haven't seen this, but it's actually a good idea. What I have seen usually people do is versioning things that they do change quite often in the quality. So basically, the prompt and the LLM. And if you have a vector store, you also need a version for that. It's not like for the Forl agent, I will say more of the things that directly determine the quality. Do you do soft releases for agents or learn as you go Google? Sorry, I'm not sure what do you mean by soft releases. And yeah, if you can post like clarification, that would be great. How do we maintain separate contexts for different users? Really good question. This is the responsibility of the backend, which maintains sessions. And based on that, it knows this question is coming from this user. So it's a typical software engineering from that perspective, maintaining different sessions. How do these products help small businesses and how it's positioned so they understand? How it helps small businesses is more of like a product question. I think the use cases that I've seen being useful is assistive tasks. So if you have a task that requires writing something or searching for something, assistive mode where basically the agent gives you drafts and you modify these drafts is going to be the most successful ones. The ones that people were trying to get like fully end-to-end automation, the quality is 80 or 90% there, and that remaining 10% is enough to ruin the whole experience. So in my opinion, the successful ones or the successful applications where basically there's assistive or human in the loop basically. Let's see. Who is responsible for backend? GenAI engineers, software engineers. So in the teams that have worked on, people are not really focusing on titles. You have people working on a team, and that team is responsible for that service. You're sorry, yeah. Rohan, did you want to say something?
Accidental click. Sorry, my bad.
Okay, no worries. So basically, it's a team that is responsible for owning a service, and they are gonna do whatever it takes to keep the things working and the quality up. That being said, these product teams are usually not responsible for the foundation model or the LLM training itself. That's completely a different responsibility. What are the most popular framework for orchestrating tools with agents and handling memory? LangChain is one of the most famous one. Google ADK is also a good candidate. LangGraph is also another option. These are code ones. The no code ones are N8N, but these are no code ones. How much does system engineering apply to building multi-agent systems? It is actually used a lot because you can tell that this back end is responsible for so many things, and many of the design discussions are actually revolved around building systems. So I think this is a really good opportunity for people who want to transition to ML and AI, is basically thinking through how to build these systems. You need just enough information to understand what's going on when using LLMs without necessarily having the skills or the background to build the LLM itself. Will we move to create new agents and LLM models by simply querying for it?